Okay, let's look at an interface with the question to implement this. We said we want to do the message encoder. An interface, use an interface named message encoder. So let's check our Eclipse. We have, I'm going to create a new project. Let's name A6 Unit 6. Yeah, I think A6 is Unit 6, right? Message encoder. So I have the interface that I did earlier. One example, name message encoder right there. I'm going to just copy and paste it right in here. So let's take a look at our message encoder. Right. So that's what it asks us to have single abstract method encode. So we're done with the point where plain text is the message to be encoded and the method returns, okay, encoded message. Now create a class. It asks you to create a class that implement the interface now. So this is a class named substitution cipher. So let's create a class, new class, and let's paste the class name there. And it's the implement the interface, right? So the interface is the message encoder. Okay. The constructor should have one. Okay, we will do constructor then. So let's implement the constructor. Public substitution cipher. Okay, let's read the requirements now. Need one parameter called shift. Define the method encode so that each letter is shifted by the value in shift. So you want the method encode too, but this is going to be parameter name shift. So let's do is as the int, because it seems like the how many position you want to shift. That's what it means, right? And define the method encode so that each letter is shifted by the value in shift. So here's the encode. We already have that because we implemented it. We require to implement it here. Now this is about logic now. Okay, so the interface is pretty much done, right? You implement the interface, right? So substitution cipher is a message encoder, right? Polymorphisms is a relationship. So now logic. If shift is 3, A will be replaced by D. Simple, right? A, B, C, D. Just shifting 3 location, replacing with D. Right? Now we understand B, E replaced with E, C replaced with F. You may wish to define a private method that shifts a single character. So how to define this shift a single characters method? Let's look at the background of computer when we talk about ASCII table. If the user pass in a lowercase a, if I shift 1, 2, 3, I get D. You see that? So that means 97 plus 3, I get 100. So these are the number representation of the characters. Characters is like actually number. That's what I try to say. Right? Because it takes a decimal number stored on the machine. So since we know that, It's gonna make your life so easy. Let me just create the driver class to show you. Let's see, the question may ask you to do that too. I'm going to name it the same. So it didn't talk about create driver, but of course you need to test that to show. So I'm going to say message driver. Okay. With the main. Now, let's just do the simple thing about if I want to print a letters. Of course, it's going to show A, correct? Let's do lowercase. A. Now, if I do +3. Right, let's see. Wow, why it show 100? What's that 100 again, guys? Look at your ASCII table. A +3 is show you D already. But in the number. That's why I tell you it's very easy. You pass in the letter, you add the shift amount is 3, right? And then what you need to do is you need to turn it back to be So how to turn it back? You can, let's see if I can they have let's see, we have to review the method. They may not take the number. It's on the characters Java doc, the character class. But let me just try to cast first to see if it works. There you go. Casting is simple too, right? Just casting it back to char. So we're done. Now, that's it for that single method. That's what it's trying to say. Alright. So now, this class asks you to create another class named Shuffle Cipher that implements the interface message encoder. So, of course, I just showing you the partial of this. You need to do the implementation on your own, right? Which I think I'm not going to cover that. Do we need to cover that? Be good, right? Well, I just create a method in message drive, the message encoder. The substitution cipher. And when encode, just call that method, right? Like public name shifter, something like that. Shifter. And of course you need to pass in the characters to shift, right? And the number of shift. And it's going to return it should return a char back. I already show you how to do that, which is from here pretty much this is going to take care of the rest, correct? And then your encode just call this to use. I'll leave that up to you. Now come to shuffle cipher. The shuffle cipher is going to do to implement again, right? With the another way is do shuffling now. That's substitution. So let's create the class shuffle cipher. New class shuffle cipher. And then you want to use an interface, so we're going to add the interface's message encoder. And doing this way is going to add the unimplemented methods for you right there. Now constructor should have one parameter called n. So let's create a constructor with the one parameter. Call n. Not sure what's that. Let's see, try to be times. Okay, so define a method encode so that method is shuffled n times. So that's gonna be int then, the number of times you want to shuffle, right? I don't really like the way that they say n, because this is a meaningful variable thing, right? So should they shuffle times the number of shuffles instead, right? Because this is a good programming practice. Okay. Change it to number of shuffles instead, and define the method encode so that the method is shuffled in n times. Has to be in number of shuffle times, right? I'll change that. Now we define. So this is constructor spelling encode, right? So we already defined it, you just need to implement it. Alright. To perform one shuffle, split the message in half and then take the characters from each half alternately. And this is how we do a shuffle. We split A, B, C, D, E, F, G, H, I as an example into half. So odd, we just odd numbers, odd letters, we just take the odd part or the middle one to the first half. And we use second half, we just use, like between A and B, we just take F, insert between it. Between B and C, we just take G, insert between it. Between C and D, we just take H, insert between it. Between H, D, and E, we just take I, insert between it. So we get encoded. Same thing. This is you want to do, just create a private method that perform one shuffle. Now we say private method, like just like the substitutions, we want to make it private, right? Why? Because it's being used just inside this substitution cipher. I don't want the one who called it to have an access to it, because shifter is going to support encode. So same. Now your shuffle cipher, you want to do the private method, right? And do the shuffle, and what say perform one shuffle. So if you happen to pass in 2, 3, 10 times for shuffle, you just keep calling this over and over again. But this one just do one shuffle, right? Because it's going to do all the work. It's going to split in half again and then do inserting between, right? Half again, for the third time, inserting between from the